Bismillahirrahmanirrahim. I thought these were interesting questions, so let's try them. The first question states, what is the sum of angles y and z? So here we're given a triangle ABC, and the interior angles of the triangle are labeled x, y, and z degrees, as you can see. And we're asked to find the sum of angle y over here and angle z. Now this is an easy question if you know what they're implying or what they're asking. This particular diagram should remind us of a theorem that we learned in geometry, and that is the exterior angle theorem. A triangle, as you recall, has interior angles like x, y, and z that are labeled over here, and then it also has exterior angle like the 140 that's given over here. So a triangle has interior angles and then it has exterior angles, which are over here. Now the exterior angle theorem states that the exterior angle is the sum of the two non-adjacent interior angles. That is, 140 degrees is equal to y plus z. Again, the exterior angle theorem states that the exterior angle is the sum of the two non-adjacent interior angles. So therefore y plus z is 140, and that is the answer to this question. Typically the question is asked the other way around. They give you y and z, and then you're asked to find the exterior angle. But this one kind of flips the question, so I thought that was kind of interesting. Now the second question states, what's the area of this triangle ABC? Now if you recall, the formula for the area of the triangle is 1/2 the base times height. The important thing to appreciate is that any of the sides of the triangle can function as bases. For example, AC can be the base. Then the height has to be the corresponding height. Now you have to understand what height means. Height is the perpendicular height from the opposite vertex. So if AC is the base, the height is this perpendicular height right there. So if AC is the base, the height is the perpendicular height, that is the altitude from the opposite vertex. And if AB is the base like this, then it's this height right here. It's the altitude from the other side like this. And finally, if BC is acting as the base, then it's the altitude. The height is going to be from the opposite end like this. And as you can see over here, by the way, the altitudes of a triangle are concurrent. Nevertheless, the key understanding here is that any of the sides can act as bases. So in this case, for example, if I chose BC as the base, then I would draw the altitude or the height from this opposite vertex like this. Now, if you do that, you observe something curiously interesting. You form a triangle that is 30, 60, 90 triangle. And that's the beauty of this question. Because as you recall, in a 30, 60, 90 triangle, the side opposite of the 30 degrees is half the hypotenuse. In this case, this is the hypotenuse. So if the hypotenuse is 6, this segment right here is going to be half of that. And that's going to be 3. And that's this segment right over here. And that's 3, if you recall. This side is going to be 3 square root of 3. So in a 30, 60, 90 triangle, the side across from 30 degrees is half the hypotenuse, and the third side is x squared of 3, as is shown here. See, now we know the height that corresponds to this base BC. So we can calculate the area. The area of this triangle is 1/2 the base, in this case BC, which is 8, times the height, which is 3 square root of 3. And you simplify this, 2 goes into 8 4 times, and the area of this triangle, 4 times 3 is 12 square root of 3. And there we have it. Now, just to humor ourselves, let's try using AB as the base. So let's see, if we use AB as the base, then we would draw this particular height over here like this, right? And this would be 30 degrees. And then we would do the same thing. The side across from 30 degrees is half the hypotenuse. So this over here, this little segment here, that's going to be 4. And this height that corresponds to the base AB, or the side AB, is this, that's going to be 4 square root of 3. Then the area of this triangle would be, again, 1/2 the base times height. In this case, the base is going to be AB, which is 6, and the height is 4 square root of 3. And then we simplify again. We get area of this triangle to be 3 times 4 is 12, square root of 3, and as you can see, it's the same. Of course, because the triangle is the same. I hope you enjoyed. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.